at Horingata now, I think you can escape. So this is the radar that has very recently come up at University of Calcutta, and just to give a brief information about our department, the Institute of Radio Physics and Electronics. So our department was founded by late Professor Shishir Kumar Mitro, FRS and Padma Bhushan, and who was one of the first in the world, to start active instrumentation for atmospheric and ionospheric probing way back in the 1920s and 1930s. This is in fact a picture I found of him with his very able student Dr. A.P. Mitro, who later on became the Director General of CSIR. And in fact, Professor Mitro and his group of students, they provided the first experimental evidence of one of the ionospheric layers, which was predicted by Heaviside and Kennelly, and of course his book, The Upper Atmosphere, which is published by the Asiatic Society. So that book still remains, as one of the very standard and initial beginner's guide to the field of upper atmosphere. Our department was the first in India to start postgraduate teaching in electronics way back in 1949. This year we are celebrating the 75 years of our department, and a number of programs are being held starting from 20th April this year. We will continue this for the next 1 year. The field station where tomorrow we will be going, this was established in 1953. In the formation of that field station, Professor Shishir Mitro was in the forefront, but the back end push or initiative was given by none other than Professor Meghnad Saha. And tomorrow, if you have the time at the field station there, you can see that we have a visitor's book where in Professor Meghnad Saha's own handwriting, we have an excerpt of what he has written on the day this field station was inaugurated in 1953, 1954, around that time. And this is perhaps one of the first manual ionospheric sounding system that was established, because in those days you did not have off-the-shelf items, so you basically have to assemble all these active instruments in your lab, and the data from that ionosound that I found was available at this Space Physics Interactive Data Resource website of NGDC. So that ionosound operated till about 1976, 1977, after which the operation was suspended because of the lack of spares. So that was a kind of end of our active experimentation, so to say, because thereafter we worked majorly with satellite beacon receiving systems, GPS or GNSS receivers, which are essentially passive. They do not transmit any kind of signal or power. They operate only in a passive only mode. So this particular project is a prestigious joint initiative of the Science and Engineering Research Board, or ACRB, under the Department of Science and Technology, Government of India, and University of Calcutta. And it's a high power system. You will get to know the details also from our people who are working there. It's a high power system, total peak power of about 950 kilowatt, and each of the transmitters has a peak power of 2 kilowatt. So basically there are 475 number of transmitters and receivers, so you have about 950 kilowatt of power, and as repeatedly mentioned that it has got 25 digital receivers. So what is important and as well as challenging is that this is a major facility and the only such radar around 50 megahertz in the entire eastern and northeastern India as well as Southeast Asia. The radars under China are further north. Okay. And this is also the first 50 megahertz active phased array radar in an Indian university. So that is a pride for us. At the same time, it's a major challenge for us because it needs huge resources of the orders of at least a few crores per year for simply operating and maintaining the entire system. We also plan to provide remote access to this facility. That means we are talking of setting up some networking kind of configuration there so that the researchers or those who are planning or proposing experiments do not have to be physically present at the site to make the experiments. They could send a brief proposal along with their requirement, which our team could check and evaluate. There will be a small committee, and after their approval, we could run the experiments, and during that experimental run, we are thinking of giving some kind of authenticated access to the users. Okay, it may not be full access to anybody anywhere, but it has to be through some authentication process, because radar is a sensitive infrastructure. Okay, that we have to remember. So university has come up with major contributions, and ACRB has provided the financial and science technology inputs. In fact, our speakers since morning, almost all of them have been members of the various committees which have been set up, but now we have a requirement to involve as many number of users from this region as well as the entire country, particularly eastern and northeastern India, to be associated with this radar. Now, one of the issues which I find in many students is that, no sir, I don't want to go into atmospheric science, I don't like that subject. Fine, you don't have to do that. As Dr. Anandan said, okay, in his talk, that if you like to work with digital signal processing, that's a core subject in any ECE or perhaps also in electrical engineering courses. So you work with that. You want to work with softwares, you design codes to analyze the data. You don't have to bother about what results will come or what will be their interpretation. So there are various avenues in which you could, through which you could get associated with the radar, not only from the perspective of hardcore atmospheric science or physics. So this is the location of the radar as far as Google is concerned, and tomorrow we will be going there. So as already mentioned, that this is the first such radar in an Indian university and the third such radar in India, the others being at SHAR and at NARL around 50 megahertz. The entire array of 475 transmitters and receivers, they are arranged in the form of hexagons, each having 19 Yagi antennas along with transmitters and receivers, and all these beams which are being generated, they could be electronically steered from the zenith direction to at least 30 degree. In fact, we have gone up to 40 degree with these beam steering softwares. And as far as the performance is concerned, it could provide height coverage up to 20 kilometer. In fact, we are going beyond that at present. Height resolution of 50 meter, but we could also get it up to 37.5 meters within the first say 2 to 3 kilometers, and 150 meter above that. And it will of course have this 25 channels, which is first in India. So in the developmental phase of this radar, we have found that although there have been several cases in India throughout, not only in India, globally I should say, when all kinds of outdoor activities have been seriously affected during this period from 2020 to 2022. But it was during this time that something was like this, the entire array was like this in 2020, then in 21, sufficient amount of work was done, and finally in 2022 we have the entire array ready. So this is just a snapshot of the radar control room. We will go to that in more details tomorrow. Some of the block diagrams of the system, which also our engineers will explain tomorrow, the signal processing steps. So when we go to the policy makers, we have to tell them that other than the domain of science or R&D, what benefit could this radar provide to the common person or to the society as a whole? So we should be aware that this region around the northern part of Bay of Bengal, which experiences some of the most severe weather conditions, starting from the nor'westers or Kalboishakhi, other kinds of thunderstorms, lightning activity. In fact, this Chotonagpur plateau to the Bay of Bengal is, it records the highest number of deaths arising out of lightning. And as a result, a number of government departments, they are coming up with a thunderstorm test bed in this particular part of the country. Other than that, we also have these tropical cyclones, like in the last few years we have Fani, Ayla and Amphan, and in fact we could do some amount of recording of the data during this cyclone Amphan itself. That was more by chance than being pre-planned, because Amphan happened in May 2020 when there was a significant amount of lockdown throughout the country. So during that time we had some information. So what gives us that edge over other kind of lower atmospheric measurement is that these radars provide the vertical wind measurement with a high degree of temporal and altitude resolutions, and which cannot be done by, say, conventional wind measurement techniques like radio sonde. So that is one of the major USPs or advantages of this kind of a radar compared to other systems which are being present. Another factor is that being established in an university, it has its challenges of limited resources, but as far as human resource is concerned, I think we get very good support from departments like atmospheric science, applied mathematics, IT, statistics, computer science, and of course our own department where we offer this electronics and communication engineering course at the undergraduate level. Our environmental science department is also interested in working on some of these pollution related studies, and they also are part of this bigger team which the university is coming up with so as to have a better utilization. A radar is not that kind of a system which a teacher can buy, put it in an almirah, lock it and say that it is mine. It is out in the open, okay. In fact, there was one, I will just give a brief example. I was once asked by some persons who were doing some audit that, sir, the antennas are all outside. So what will happen if they all get wet? They will be all damaged. So I replied that these antennas are meant to be outside and meant to work under that kind of a situation where there will be rainfall, very heavy rainfall. There may be hailstorms as well. Okay, that region around Horinghat experiences really big size hailstones sometime in a year. So these are some of the issues which are there, but which has to be resolved. So as a step towards generating awareness and also building up some kind of an user base, way back in 2019, when the radar was not even ready, we had a brainstorming meeting where a number of universities and institutes from around the country, they have participated. Many of them from the northeast, like Dibrugarh University, Guwahati, Assam. Then there was also this Kohima Science College and other institutes from other parts of the country as well. So Addis was there also, KUSAT, and of course Dr. Patra was there from NARL, IITM Pune, and IIT Indore, and also our local partners like ISAR Calcutta, which is just next door almost, and IIEST in Shibpur. So far in this particular facility, what we have done is we have done some kind of coordinated and co-located radio sonde launches with Vikram Sarabhai Space Center, and as from that we have a published paper. Then with the kind cooperation from NARL, we had a campaign mode ionospheric observation, from which also another paper has been published in Radio Science. We have been a part of this coordinated campaign for the Indian summer monsoon of 2021. All the 5 radars that I was mentioning in the morning, they were a part of that. Then some university level user awareness program. Then in the European Union, they had, at the ISCAT node, they had some kind of online training which our project staff, they undertook for 6 months time, during April to September. We have a dedicated website, custr.org, where you can go and check for all the updates as and when available. And for greater reach among the younger students, we also have a YouTube channel. And more recently, we have also participated in this ISRO National Space Science Exhibition, which was held in December last year. So, what the university plans, why all of them are here, is that there should be core research activities and as well as collaborative work with other institutions and universities. Faculties and researchers from those places or those institutions who are already experts in this particular field, they will be invited for maybe a few weeks time, or sometimes maybe a few months time, according to their availability, and they will be available at our institute, and researchers who are associated with them could come and discuss and do experiments during that particular point of time. There will also be provision for inviting national and international experts as adjunct faculties in the university or in a particular department. Students, they could undertake summer internships and projects. In fact, already using the radar, there have been, I think, at least 4 MTech projects which have been done. Then training students, and of course for capacity building in a university system, that is a very important one. This is the website that I was talking about, and on YouTube, if you just type CUST radar, you will get all the different kinds of programs that we have. You can get a glimpse of that. So when this radar became operational last December, one of the first things that we did was to do some kind of initial comparison of the radar calculated wind measurements with IMD. IMD, the nearest observation is at Damdam Airport, and we got the data from that, the aerial separation being about 30 kilometer. And this was done from Damdam Airport. Actually, they they make the measurements twice a day at 5:30 in the morning and 5:30 in the evening. So during those times, we had made the measurements, and we compared the results with them during that period of time. Then, as per the suggestions from NARL, we are in very close contact with them. We have got some signatures which we may believe, which we believe are perhaps linked to mesospheric echoes very recently, only in June this year. And of course, because our university has got a long tradition of ionospheric research, so we started observation from last September in the ionosphere mode, and this night of 20th September was the one when we first got some kind of signatures at heights of around 250 to 300 kilometers in the early evening hours, as you can see. And the signatures that we have found from the radar, they are often patchy in nature, and they occur at altitudes of roughly, mostly within the 400 kilometer and in the pre-midnight hours. Okay. In the post-midnight hours, we have not too many observations. Then on 3rd October, there was this very huge structure which we noted. It extended almost up to 650 kilometers, as you can see over here, and that also occurred during about in the pre-midnight hours, around 2100 hours in local time in IST. So this is something which we have observed from our radar in the very some of the very early observations of ionospheric signatures. This March and April also, there have been some cases that we have noted about of ionospheric records. Now, IIT Indore, they have a group, they have a department of astronomy, astrophysics and space engineering, and they are more interested in doing passive mode radar astronomy, and they have done some sun tracking as well as Virgo tracking. And in fact, one of our BTech students, Arjun, he did some experiments and he presented that at the 44th meeting of the Astronomical Society, and he in fact got Best Poster Paper Award for that this year. Another area, major area where many departments of the university are collaborating together, as you can see, is that of severe weather and environmental analytics. And all these departments, radio physics, electronics, applied math, stats, atmospheric science, IT and environmental science, they are involved in this particular exercise, and hopefully some major research activity could be generated out of this collective effort. There have been some papers which have been published or under review in journals like these two, and the media also, they have reported sometimes, not always, this kind of a radar which is coming up. And the funding agency, Science and Engineering Research Board, they have also visited the radar site after it became fully operational. So I leave you with this, but just request you to wait for maybe another 2.5 minutes, because there's a short video that I would like to see, that I'd like to show you. ওই ভিডিওটা চালান, ওইটা ওর আগেরটা এইটা।
University of Calcutta is setting up a stratosphere-troposphere (ST) radar facility operating at 53 MHz frequency at Ionosphere Field Station IFS within Bhata of the university. This facility is fully funded by the Science and Engineering Research Board (SERB), Government of India. This is the first such radar in an Indian university and the only such system around 15 megahertz in the entire eastern and northeastern India and Southeast Asian longitude sector. This facility is being developed as a national facility to be available to all academicians and researchers across the country and outside. There will be provision of remote access to this facility when it becomes This radar could be used for disaster management, pollution studies, flight planning, missile launch, space shuttle support, etc.
Thank you, and I will be failing in my duties if I don't mention the very young person who has made this video. It was not some very highly professional person who has made this. Arijit, please. So he actually arranged all these drones and such things, and because we could not afford a professional, video maker that will cost a huge amount of money. So anyway, that is all that I have to share with you now. So if you have any quick question, you can ask, or else we can have tea outside, and we look forward to meet you again tomorrow morning at 8:15 when the two buses will start from the site.